NEC 300.15 cone states that conductors for general wiring in raceways or cables concealed or exposed shall be of the rubber-covered type or type TWT of NMC or AC. Romex, which is also known as type NM cable, is therefore permitted for use in raceways or cables, whether concealed or exposed, in buildings over 3 stories above grade. Regarding commercial kitchens and multi-dwellings, the NEC itself does not specifically prohibit the use of Romex. However, it is important to emphasize the significance of checking with the local building code for any potential additional requirements that might be applicable to commercial kitchens. It's crucial to understand the scope of NEC 300.15 cone as it relates to different wiring methods. The NEC outlines acceptable wiring methods for various applications. The reference to rubber-covered type TWT of NMC or AC conductors sets a baseline for what is generally permitted. The allowance of NM cable or Romex within this section is a key point. The interpretation provided is that Romex is permitted for use in buildings exceeding 3 stories, which may seem counterintuitive to some. This is because the NEC does not have a blanket prohibition against it in such structures. However, other factors and local codes might still restrict its use. When it comes to commercial kitchens, the absence of a specific prohibition in the NEC doesn't automatically equate to an endorsement. Commercial kitchens often have unique demands due to heat, moisture, and other environmental factors. These conditions might necessitate more robust wiring methods than NM cable. Therefore, local building codes often have more stringent requirements for commercial kitchens to ensure safety and prevent hazards. Always consult the relevant local codes and authorities having jurisdiction AHA to determine the permissibility of Romex in commercial kitchens. The NEC provides a broad framework, but local amendments and interpretations can vary significantly. In summary, understanding the NEC provisions and the importance of local codes is paramount for safe and compliant electrical installations. Always prioritize safety and compliance by staying informed and consulting with qualified professionals. When considering wiring methods for different types of buildings, it's important to be aware of the various cable types available and their respective applications. Type NM cable, commonly known as Romex, is often used in residential wiring due to its ease of installation and relatively low cost. However, its suitability for commercial or multi-story buildings is subject to certain limitations as outlined by the NEC and local codes. The key lies in understanding the specific requirements for each application and ensuring that the chosen wiring method meets the safety and performance standards. The phrase buildings over 3 stories above grade refers to the height of the building and its potential impact on fire safety and structural integrity. In taller buildings, stricter regulations are often in place to minimize the risk of fire spread and ensure the safety of occupants. These regulations may include restrictions on the use of certain materials or wiring methods that are deemed less fire-resistant or more likely to contribute to the spread of flames. Commercial kitchens, in particular, present unique challenges due to the presence of high-temperature appliances, flammable materials, and frequent cleaning activities. These factors can create a more hazardous environment compared to typical residential settings, necessitating the use of more robust wiring methods and equipment. Therefore, it is crucial to carefully evaluate the specific requirements for commercial kitchens and select wiring methods that can withstand the demanding conditions. The NEC provides guidelines for selecting appropriate wiring methods based on factors such as voltage, amperage, environmental conditions, and occupancy type. These guidelines are intended to ensure that electrical systems are installed safely and reliably, minimizing the risk of electrical shock, fire, and other hazards. However, it is important to remember that the NEC is not a substitute for sound engineering judgment and professional expertise. Consulting with qualified electrical engineers and contractors is essential for ensuring that electrical systems are designed and installed in accordance with all applicable codes and standards. The concept of local building codes is crucial to understand. Local jurisdictions often adopt and amend the NEC to address specific needs and concerns within their communities. These amendments can vary significantly from one location to another, so it is essential to consult with the local authorities having jurisdiction to determine the applicable requirements for a particular project. Local building codes may also include additional regulations that are not covered by the NEC, such as requirements for energy efficiency, accessibility, and environmental protection. These regulations can have a significant impact on the design and installation of electrical systems, so it is important to be aware of them and incorporate them into the project planning process. Understanding the difference between general wiring and specific applications is also important. The NEC often provides separate requirements for general wiring and specific applications, such as commercial kitchens, healthcare facilities, and hazardous locations. These specific requirements are intended to address the unique hazards and risks associated with each type of application. For example, commercial kitchens may require the use of liquid-tight conduit to protect wiring from moisture and grease, while healthcare facilities may require the use of isolated power systems to prevent electrical shock hazards. It is essential to identify the specific requirements for each application and ensure that the electrical system is designed and installed accordingly. The phrase rubber-covered type or type TWT, OFF, NMC, or AC refers to different types of insulated conductors that are commonly used in electrical wiring. Each type of conductor has its own specific properties and applications, and it is important to select the appropriate type of conductor for each wiring situation. For example, type TW conductors are commonly used in dry locations, while type UF conductors are suitable for direct burial applications. Type NM cable, or Romex, consists of two or more insulated conductors enclosed within a non-metallic sheath. It is commonly used in residential wiring for branch circuits and feeders. The abbreviation AHJ stands for Authority Having Jurisdiction. The AHJ is the entity responsible for enforcing the NEC and other applicable codes and standards in a particular location. The AHJ may be a local building department, a state electrical board, or another regulatory agency. It is essential to identify the AHJ for a particular project and consult with them to ensure that the electrical system is designed and installed in accordance with all applicable requirements. The process of consulting with qualified professionals is essential for ensuring that electrical systems are designed and installed safely and reliably. Qualified electrical engineers and contractors have the knowledge, skills, and experience necessary to navigate the complex requirements of the NEC and other applicable codes and standards. They can also provide valuable insights and recommendations to help ensure that the electrical system meets the specific needs of the project. When selecting electrical engineers and contractors, it is important to verify their qualifications and experience. Check their licenses and certifications, and ask for references from previous clients. It is also a good idea to review their past projects to get a sense of their capabilities and expertise. The concept of electrical safety is paramount in all aspects of electrical work. Electricity can be dangerous, and it is essential to take precautions to protect yourself and others from electrical shock, fire, and other hazards. Always follow safe work practices when working with electricity, and use appropriate personal protective equipment. If you are not qualified to work with electricity, do not attempt to do so. Hire a qualified electrical professional to perform the work. When working with electrical equipment, always de-energize the circuit before touching any wires or components. Use a voltage tester to verify that the circuit is de-energized. Never work on electrical equipment while it is wet or damp. Be aware of the potential hazards associated with overhead power lines. Keep ladders, tools, and other objects away from power lines. If you are working near power lines, contact the utility company to request that the power be turned off. The process of staying informed is essential for keeping up with the latest changes and updates to the NEC and other applicable codes and standards. The electrical industry is constantly evolving, and new technologies and regulations are being introduced all the time. It is important to stay informed about these changes to ensure that you are designing and installing electrical systems in accordance with the latest requirements. There are many ways to stay informed about the electrical industry. You can attend industry conferences and seminars, read trade publications, and subscribe to online newsletters. You can also join professional organizations such as the Institute of Electrical and Electronics Engineers IEE and the National Fire Protection Association NFPA. The importance of understanding the various factors influencing wiring method selection cannot be overstated. Factors such as ambient temperature, corrosive environments, mechanical stress, and the presence of flammable materials all play a critical role in determining the appropriate wiring method for a given application. For instance, in high-temperature environments, conductors with high temperature ratings may be required to prevent insulation breakdown and potential fire hazards. Similarly, in corrosive environments, wiring methods that are resistant to corrosion, such as PVC-coated conduit or stainless steel cable, may be necessary to ensure long-term reliability. In areas subject to mechanical stress or physical damage, wiring methods with robust protection, such as rigid metal conduit or armored cable, may be needed to prevent damage to the conductors and maintain electrical safety. And in areas where flammable materials are present, wiring methods with appropriate fire resistance ratings and installation practices may be required to minimize the risk of fire ignition and propagation. The NEC provides detailed guidance on selecting wiring methods based on these and other factors. It is essential to carefully review the applicable requirements and consult with qualified professionals to ensure that the chosen wiring method is suitable for the specific application. The concept of approved as used in the NEC is defined as acceptable to the authority having jurisdiction. Therefore, even if the NEC permits something, the AHJ has the final say. Local amendments or interpretations of the code can further restrict or clarify the requirements for specific applications. The NEC serves as a comprehensive guideline, but it is not a substitute for local regulations and the professional judgment of qualified individuals. It's always recommended to collaborate closely with local inspectors and engineers to ensure full compliance and to address any unique circumstances that may arise. The responsibility for ensuring a safe and compliant electrical installation ultimately rests with the individual or organization performing the work. This includes not only adhering to the NEC and local codes, but also exercising due diligence in selecting appropriate materials, employing qualified personnel, and implementing proper installation techniques. Failure to do so can have serious consequences, including electrical shock, fire, property damage, and even loss of life. Therefore, it is essential to approach every electrical project with a commitment to safety and compliance, and to prioritize the well-being of all individuals who may be affected by the installation. In addition to the NEC and local codes, there are also a number of other standards and guidelines that may be relevant to electrical installations. These include standards from organizations such as the IEE, the American National Standards Institute ANSI, and Underwriters Laboratories UL. These standards provide detailed specifications for electrical equipment, materials, and installation practices. They are often referenced by the NEC and local codes, and compliance with these standards is often required for electrical installations. It is important to be familiar with these standards and to ensure that all electrical equipment and materials used in a project meet the applicable requirements. The NEC and related standards are updated on a regular basis to reflect changes in technology, industry best practices, and regulatory requirement. It is essential to stay current with these updates to ensure that electrical installations are designed and installed in accordance with the latest requirements. Subscribing to industry publications, attending conferences and seminars, and participating in professional organizations are all effective ways to stay informed about the latest developments in the electrical industry. The legal and regulatory landscape surrounding electrical installations can be complex and ever-changing. It is important to understand the legal implications of non-compliance with the NEC and other applicable codes and standards. Failure to comply with these requirements can result in fines, penalties, legal action, and even criminal charges. It is also important to be aware of the liability risks associated with electrical work. Electrical contractors and engineers can be held liable for damages or injuries resulting from negligent design or installation practices. Therefore, it is essential to carry adequate insurance coverage and to implement appropriate risk management strategies. The long-term performance and reliability of electrical systems depend on proper maintenance and inspection. Regular inspections can help identify potential problems before they lead to failures or safety hazards. Maintenance activities such as tightening connections, cleaning equipment, and replacing worn components can extend the lifespan of electrical systems and improve their efficiency. It is important to establish a comprehensive maintenance and inspection program for all electrical installations. This program should include regular inspections by qualified personnel, documentation of inspection findings, and timely implementation of corrective actions. The NEC contains chapters covering special occupancies, special equipment, and special conditions. These chapters provide specific requirements for installations in locations such as hazardous areas, healthcare facilities, and swimming pools. They also address equipment such as elevators, electric vehicles, and renewable energy systems. These specialized requirements are designed to address the unique safety hazards and operational considerations associated with these applications. The NEC includes detailed requirements for grounding and bonding of electrical systems. Grounding and bonding are essential for protecting against electrical shock and preventing equipment damage. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices to trip and de-energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current to flow. The NEC specifies the size and type of grounding and bonding conductors, as well as the methods for connecting them to the electrical system. The NEC includes tables for determining the ampacity of conductors. Ampacity is the maximum current that a conductor can carry continuously under specified conditions without exceeding its temperature rating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. The NEC tables provide ampacity values for different types of conductors under various conditions. It is important to select conductors with sufficient ampacity for the intended application to prevent overheating and potential fire hazards. The NEC contains requirements for overcurrent protection. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds its rated ampacity, causing the conductors to overheat. Short circuits occur when there is a direct connection between two conductors of different potential, resulting in a very high current flow. The NEC specifies the size and type of overcurrent protection devices that must be used in different circuits to protect against these hazards. The NEC addresses voltage drop in electrical circuits. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. The NEC contains guidelines for selecting appropriate wiring methods for different environmental conditions such as wet locations, damp locations, and corrosive environments. The NEC outlines the requirements for cable support. Cables must be properly supported to prevent strain on the conductors and to ensure that they are not damaged. The NEC specifies the types of supports that must be used and the maximum spacing between supports. The NEC includes requirements for the installation of electrical boxes and enclosures. Electrical boxes and enclosures are used to protect electrical connections and to provide a safe and accessible location for wiring devices. The NEC specifies the types of boxes and enclosures that must be used in different locations and the methods for installing them. The NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory, such as UL. Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. The NEC contains requirements for the installation of lighting fixtures. Lighting fixtures must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect lighting fixtures and the methods for supporting them. The NEC addresses the installation of appliances. Appliances must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect appliances and the methods for grounding them. The NEC contains requirements for the installation of motors. Motors must be installed in accordance with the manufacturer's instructions and the NEC requirement. The NEC specifies the types of wiring methods that can be used to connect motors and the methods for protecting them from overloads and short circuits. The NEC addresses the installation of transformers. Transformers must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect transformers and the methods for protecting them from overloads and short circuits. The NEC contains requirements for the installation of generators. Generators must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect generators and the methods for protecting them from overloads and short circuits. The NEC addresses the installation of renewable energy systems, such as solar photovoltaic PV systems and wind turbines. Renewable energy systems must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect renewable energy systems and the methods for protecting them from overloads and short circuits. The NEC contains requirements for the installation of fire alarm systems. Fire alarm systems must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect fire alarm systems and the methods for protecting them from damage. The NEC addresses the installation of communication systems such as telephone systems, data networks, and cable television systems. Communication systems must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect communication systems and the methods for protecting them from damage. The NEC contains requirements for the installation of low-voltage systems such as security systems, landscape lighting, and irrigation systems. Low-voltage systems must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect low-voltage systems and the methods for protecting them from damage. The NEC addresses the installation of electric vehicle charging systems. Electric vehicle charging systems must be installed in accordance with the manufacturer's instructions and the NEC requirements. The NEC specifies the types of wiring methods that can be used to connect electric vehicle charging systems and the methods for protecting them from overloads and short circuits. When working on any electrical system, always verify the local codes and regulations, as they supersede any general guidelines. Always consult with a qualified electrician or electrical engineer to ensure compliance and safety.